Alright, I've jumped ahead a little bit, getting the engine out here to the garage because I need to get the dry sump stuff figured out, and I gotta finish up this job so I can get it out and get the race car in here so I can get some parts off of that, because the plan is to take this thing to the dyno on Monday, and it's Wednesday now. One of the things I did was I jumped ahead and I got the spark plug wires made. I started with a fresh set. They look like they're kind of hanging off. The plan is at some point I'll drill and tap into these valve covers, and I'll make a mount to hold them up, just to pin it there. That should keep them nice and tucked away from the headers and anything else that's going on in the chassis. If you haven't seen it before, I just did the zip tie method for wire looming. And that just has to do with you put one zip tie across and then you put one sideways in between them. This works really good for keeping the wires separated enough that they don't have to worry about any cross interference. And it's nice because you can pull them down and lock them in place so there's no sliding back and forth either. To give a quick little demonstration of that, if these two plug wires I wanted to hook together, because they were going to two different spark plugs, and I wanted to hook them together here, you take one zip tie, get it started, and then you take the second zip tie, you could loop it in line with the wires. And you get that, and you just kind of pull them both down a little bit at a time till you get down to something like this. Then, depending on how you want to visually put this, like if I want this to be the nice looking side, I can snug up that center one until it's properly separating them, and I can snug up the other one. We just clip the tails off, and now it looks like that. Now if I wanted to get a little more in depth here, I could have flipped that one around and had it down here on the bottom so that it'd be completely smooth on the top. It's something it takes a little more thinking about when you're laying it out to try to make it perfect, but the big thing here is rather than buying the plastic clip-on wire looms and you can only put them in certain places and they don't hold them that great, this holds them well because, as you can see, they're locked in place. They're not going to slide or pull. And in the case of what I got on what I have on the engine over here, I'm able to make each side nearly identical, even to the point where as they go on to the distributor, they're fairly evened up with the firing order even. I got the water pump modified where I tapped this hole, which is the heater return, for 3/8 MPT. That way I can run a fitting to loop into my cooling system the way I want to. This is a flow cooler pump. They make the two different lengths that Oldsmobile have. I have started going with this pump exclusively because they're the only ones that have a proper, like, aftermarket billet impeller to improve cooling. Everything else I've come across just has the same old stock style of varying designs, but nothing has a oversized wheel like this. So if we're putting the gasket on, we're going to use some of the shellac gasket maker again. I'm going to put it on the pump this time instead of on the timing cover. Versus before we put it on the block to put the timing cover one on, I'd rather put it to the pump because if we ever have to take it off, this is the more complicated surface. It has a better chance of sticking to here without getting damaged, and if for some reason I gotta replace the water pump, most likely that gasket's gonna end up damaged anyway. But as far as getting the holes and stuff lined up, it's much easier to stick it to the pump versus lining it up on the timing cover. So we're just gonna Put a thin little layer on. Same as before, you don't need a ton. Just gotta get enough on there to have it tack up. There are several different gasket styles if you're reusing a pump for an Oldsmobile. I believe there's 3 different styles. This is the gasket that came with the pump, so I know this one will be right. And it already test fit it. Now we're just gonna lightly push on it, get that tack up and hold it in place. Once we got that set, now we're ready to stick it on the engine. I already made sure I had my bolts ready to go. The Oldsmobile uses 4 5/16 and 4 1/4" bolts. I usually want to start with the 5/16 ones since they're the ones around the water ports. There's quite a bit of slop in the holes, but I just want to kind of get all the bolts started before I go torquing anything down. If you're using factory style stuff, 2 of these are going to be studs. I believe this one and the opposite one, so the ones below the water ports, I believe are the 2 factory studs. I don't need any of that for my application, so I've just gone to these flange head bolts. I like the flange head stuff because it spreads out a little bit more without having to run a washer. And they look nice. I got them started. I'm just going to snug stuff up. Just going to bounce around crisscross. Kind of pull everything down snug. You do want to make sure you have the correct length bolts, especially on the 2 lowers for the 1/4", because they do pass through the timing cover, and if you have a way too long of a bolt and try to stick it in there, you run the risk of hitting the timing chain or the cam gear. So you want to make sure they're just long enough to be getting through the threaded portion, and they're just flush with the backside of that little dimple that's threaded. So we can snug them up. I won't be needing this water port on the dyno, so I'm just going to put a regular pipe plug in it. As I did with the intake plugs up here, I'm just going to use also a little of this shellac gasket maker. I mean, they make, pipe thread sealer stuff, but that stuff always ends up so runny and liquidy. I've never really been happy with it. So I just use this stuff because then it's one less thing, different type of stuff I have to keep in the shop. I need to get the dry sump remounted, which means putting the brackets back on, and then I can get the pump on here, get my lines rerouted. I'm going to have to end up building something to hold the tank for at the dyno. I already had that figured out for in the car, but need to figure something out for the dyno, make a bracket, probably going to put it on the driver's side, and then just make sure that I have lines to get it all put together. Alright, the plan is to go to the dyno on Monday with the new engine. In order to do that, I need the balancer, some of the front drive assembly stuff so I can run the dry sump pump off of the car. So I finally got the other project out of here this morning and got this thing in here starting to thaw out. This cover was snow just a little bit ago. I've already pulled the wiring and stuff out. I'll be popping the front clip off, but mainly I just need to get to those parts that I need to get the drive system figured out for the water pump and the dry sump pump. And then if I have time, I'll get to the headers. Otherwise, if not, I have a second set of headers, but I'd rather have the chassis headers. That way everything's the way it will be once it's in the car, so that I can have this thing ready to go on Monday. It is now Saturday afternoon, so I got quite a bit of work to do yet, but shouldn't be too much of a problem. I also need to pull all the EFI and that associated wiring off the car and figure out a way to mount it on the new engine as well. But hopefully I'll get that progress. Alright, it's time to get the balancer put on. I need to do that so I can figure out the spacing and everything for the Mandrel drive. And I'm going to need it anyway because it's the only good one I have. I'm sure as hell not putting a stock one on here. So before we do that, we want to put a little oil on the seal surface. Can, you know, just kind of get your finger up in there and push it around a little bit and take your rail gun and just shoot it up in there. Also going to want to put it on the seal surface of the balancer. Use some of that. Put a little on the inside too. It'll help with installation. This here is a Harmonic balancer installation tool, so I just got that set up and ready to go. The excess there. So to use this tool, we're just gonna usually come with different thread stuff there. I'm not bottoming it out completely in there because it will jam and make it difficult to take back off afterwards. So you leave it a thread or two out from bottoming. Just kind of get it started there. Then you can use this bearing type thing. As you can see, it doesn't fit very well on this balancer itself. So we shall see what we've got to help with that. I think I've used this washer for that. That's why it's all bent out of shape. So with that, this nut started. Same thing here on the threads. Doesn't hurt to add some lubrication to it. I can only imagine that this nut is like a grade 5 or even less. Who knows really. Oh, we're just gonna twist on. You can see here it starts turning that one. That's what we don't want to happen. And bottom that out. So we'll just support it, and then we'll crank this nut down. I'll let it turn a little bit. It'll get a longer swing. If this is the first time you're putting a new balancer on, typically you need to measure the snout of the crankshaft and the bore of the balancer. Not so much with like a stock replacement, but definitely with aftermarket balancers. They can tend to be a little small on the inside and they need to actually be honed to fit. Fit being like as 1 to a 0 press fit or something like that. I don't recall exactly what the number is, but you don't want to have like a 5 thou press fit on there. You're actually going to break the balancer hub. It looks like my timing tab there might be a little too low. Oh, that's actually jammed up against the back, so I won't be able to use that. I better take that off before it gets stuck in there. Be another part I have to pull off of the engine that's in the car. Honestly, I'm not too surprised about this. The balancer tab, the timing tab rather. I've got a pile of these things laying around from different Oldsmobiles that I've taken apart. They all seem to be a little different. I've only ever had a few that actually matched up and were the same, and ooh, we just stopped in time for that. Oh, better get this swapped out first. Yeah, I'm not surprised here. These plastic ones tend to be the ones that fit most of the time. So, can get that started. I also have an adjustable one here, but I don't know that it's set for this yet. I haven't had a chance to really put a stop on here and crank it over with a dial wheel to make sure that 0 is 0 as far as everything's concerned there. You may think, oh, that's kind of weird. It has 0 right on the balancer. Yes, but that doesn't always line up with the timing tab. I'm pretty confident with these styles. I've used them more than anything else. The little plastic ones seem to fit the best anyway. And I think when I have bothered to check them, they've been either dead on or maybe 1 degree off at the most, but they're usually pretty close. Now, if it was all of a sudden 3, 4, I mean, hell, even 2 degrees really, because it's a little more than you want to see. Because it might not make that big a deal for getting the engine running and going and such, but it does become a big deal when you're setting timing and trying to make peak power. Because if you dyno a lot of the same engine and find a number that works, you can usually set similar engine builds to the same. Like for an Oldsmobile like this, I've put enough of these things on the dyno of different configurations where they all end up being 35 degrees is where they make best power. So I've set it for 35 degrees, but I've also done enough dyno testing to know that at 34 degrees, it's down 2 horsepower, which, you know, 2 horsepower is 2 horsepower, it's fine. But if it's 36 degrees, it can be down 5 horsepower. And at 2 degrees, it's down, or 2 degrees too much, which would be like 37, it could be down 10 or more horsepower. Timing becomes very detrimental when you have too much in most cases. Some engines are actually goofy where there can be a whole timing sweep and they actually don't care what the actual timing is, because over a sweep of like 8 degrees it makes the same amount of horsepower. But I've only seen that once. I've seen way more times where too much timing makes the power drop off significantly versus being a little under-timed. You're down on power, but not nearly what you would be if you had too much timing in it. So we just used our tool, we spun it in until I could feel it bottom out. Big thing here is not so much to make it tight, it's just to get the balancer installed, get it bottomed out or close to it, and then you can have the bolt threads finally catch and drag it in the rest of the way. Now, because of the mandrel that I'm using for the drive system from Jones, I have this ARP bolt that then is shaved down a little bit, and then I had to cut down the washer that came with it as well. I'll put some Loctite on there and get it installed. Now the torque spec on this is something stupid because it's 3/4 16 thread. I believe the last time I checked specs there was like 180 250 foot-pounds. Like it's something ridiculous, and honestly, tight is good. So I'm just not worried about putting it on with a gun, because otherwise I gotta get a breaker bar and everything else to try to stop it and then torque it up. But we get it right there. It stopped moving. We'll just give it a couple extra. Be plenty tight. In case that's freaking you out that I'm not going to torque that down, I've done this, I don't know, I can't even count how many times I've done this. They never come loose. But the thing is, you got Loctite on there. It's at a, I don't know what that gun's rated for, but it's a lot. It just, I don't know, it's not going to come loose. It ain't like it's a small block Chevy where it's only got a 7/16 thread and it only needs to go to like 40 or 50 foot-pounds or something like that, where you very much run the risk of stripping it out. That's not the case with an Oldsmobile. It's got such a big thread in it. So, ready to get this mandrel put on. I'm going to... It's got a bunch of different places it can go. It doesn't really matter where it goes at. I'm just going to line it up with my old marks, witness marks I can see. These are only 3/8 bolts, so we don't want to go crazy with them. They're also got this shoulder on them, and it fits pretty tight to this mandrel. So I kind of gotta bring them all down at the same time. I just don't want to torque it over in the bore, because the balancer's aluminum, the mandrel's aluminum, and when we start shaving material off, it's gonna lose its fit. So the last thing we want is it being ended up off center or twisted, where all of a sudden this mandrel's doing a big floppy whatever deal while it's turning. It's going to be likely to throw belts at that. These ones I will torque up. There's not really a spec for it, but it's a 3/8 bolt, so 45 should be alright. If you're wondering, I'm not making these torque specs up out of my head. There's sheets you can get or print off something online. Just look up that there's certain fastener sizes that there's industry standard torque specs for. And as long as you stick to that there, you're not going to risk stripping or snapping off a bolt. So now I get the water pump on. The water pumps are actually 5/16 fine thread. I make a habit of taking the studs out of old pumps just to save them, because otherwise you gotta try to source a 5/16 fine thread stud and 5/16 coarse outer end. Or you just get a bolt with fine thread, but trying to line all that shit up through a pulley and everything, it's just a pain in the ass. I don't like doing it. So we're just going to use some older studs that I had saved. This one might be a little messed up. See if it'll go. It will not, but I think I have a die for that to save it. Alright, there we go. The die worked. So I'm just going to run these in as far as I can with my fingers anyway, here to start. Now you could get a stud socket and torque them in there a little bit if you felt like it, but really by the time we tighten up the outside for the pulley onto here, it's going to kind of lock everything, and it'll probably turn those a little bit till they bottom out anyway. Now we know that the pulley will go on here, and I'm not going to get, not going to get too worried about pushing it in all the way right now, because I'm not exactly sure where it's going to need to end up. I know this pulley is going to need to go to the back side, which should land about where the power steering was on the old engine. So then I should be able to just install this the way it was and still run the water pump belt. So hopefully there ain't too much screwing around with that. But first we need to find out where the heck the pulley for that's going to go. Got this beveled washer that has to go on there to start. We can put on that. I'm not too worried about, there's a keyway in here, I'm not worried about that right at the moment. Let's see what, that belt's way too long. The water pump belt looks too short. Is this, I may have to loosen that up yet. There, that should work. Actually, this is my water pump belt, but I've got a spare, so that should work out well. Otherwise, these were the belts on an old setup, but yeah, of course that's way too long, so we have to use both water pump belts. But we can slip this on here for starters anyway. Good, and it's not bottomed out all the way, so I'm not going to be putting excess tension on it. Ooh, however, it's kind of the front edge. But that should stay on there. Oh, I can loosen up the set screws here though and pull that pulley out a little bit. That'll help with alignment. So, alright, now that I know that that's going to work, leave that alone. Definitely going to have plenty of room to run that water pump pulley there, so I can put this on. And I got the spacer I had to make to get it to fit, because that's set up for a small block Chevy. me just tap this the rest of the way in. Or get a bigger socket even. Never underestimate what a socket can do. Plenty of uses beyond socket stuff. So I ended up running first washers. Then lock washers. And finally a standard nut. A lot of this is, from what I remember, I feel like I've taken apart a lot of stock engines that had this set up on them. Rather than like a flanged head or serrated or anything like that, they seem to be set up like this. So, go the right way. Hope my heater in the background's not making a ton of noise. It's only like 15 degrees here today. So now this makes kind of a big pain in the butt for trying to tighten these things up. Typically I'll end up with either a pry bar or something with a wrench. Now this is my water pump pulley. I'm going to want to get it lined up pretty much vertical there. I'll just take my belt again, get it started. Push it on. I want it to run right about there somewhere, so I'll just spin the water pump. It'll kind of self-align, and then now I can look at the space I have in the back there. So now I need to fill this gap. And I have a bunch of different spacers and stuff I use. I know I need to run this one for the I don't know, retainer, if you'll call it that, for the belt on this side. So if I set that there, I can just start stacking stuff in there. Doesn't quite look like I can get two of the big washers in, but I have these smaller ones in there. They got quite a bit of gap yet. Wonder how far off it is with just two big ones. Oh, I can just barely not get the two larger ones in there. Look at that, there it pops right in. And then I mean we're only going to move ourselves out, not even the thickness of this. So I'll put both thick washers in, that'll stack in there like that, and then we got our spacing the way we want. Alright, now I'm ready to start final assembling this drive system. So we need to be putting these little keyways in. I rotated the crank so that it'd be facing up. It makes it a lot easier. We need to have our belt guide, and the gear goes on, and the other belt guide. Two spacers we're going to be running. Belt guide for the water pump pulley. Add the keyway, put that gear on, add the other belt guide, and then we just got to fill up the rest of the space. which typically ends up being the rest of the spacers. Oh, we'll put the little ones on, the big one on, and then I'll have this hexagonal one as a way to rotate the crank. So, but it needs a keyway. We gotta put that in first, and then we can put that one on, and then it all gets encapsulated with this 3/4 or 1/2 inch bolt that goes in here. So hold it in place. Make it decently tight. I'm not too worried about this one back now. It's got 1.25 inch of thread engagement. It's a ton of thread engagement in there. So. Now we take our belts. Let's see when there's the. It's a 3 years old used one. We'll put that one on the water pump because I'd rather lose water pump than oil pressure on the dyno should something happen. And then now we can't spin this to get it to engage, so we gotta push our pump in so we can slip that over. There we go. And same thing here. Although I might need to pull this off and put it back on there because I'm dumb and got ahead of myself. It's hard to remember all this stuff when you only do it once a year. And all this stuff. Pull the other one keyway out. Get that one on there. We'll spin them both together. There we go. That makes it way easier. Push it in. And just rotate, line my keyway back up. Push keyway in. Let me pull this business back on. Alright, here we go. Now that all that's lined up, we still need to pull this out a little farther. I don't know how well you can see it, but like I mentioned before, it ain't quite straight. So, if I check the measurement, I got 1.5 inches to the belt up there, and I got 1.11 down here, and I'm already at the edge of this pulley, so this pulley definitely needs to come forward. If you're watching this for Oldsmobile stuff, it is an Oldsmobile. Obviously, I don't know, I'm probably the only person in the world that's running one of these things, but you know, I'm probably the only person in the world that time attacks their freaking Oldsmobile too, so kind of take what you can get, I guess, there. We'll have a couple more things that are actually just everyday stuff. Man, that thing's on there. Oh. Hope that was... Wait, alright, it's moving. And there, that's flush. So we'll leave it right there. Inch and 9/16, so now it's straight. Should happily center up there because of the guiding while it's running. and shouldn't have a problem with that. If we got to move it any more than that, then I guess I'll deal with that after it's fired up on the dyno. Alright, installing the thermostat housing. Because we're going on the dyno, it will be the temperature will be regulated by the dyno, so we're not putting a thermostat actually in here. Depending on the gasket you get, it might be just a standard gasket, in which case if I was putting the thermostat in here already and it was going to be going straight into a running car, I would put the shellac that we've been using on the housing, stick a gasket to it, that way the thermostat's underneath. If you ever have to change it, maybe it'll save. I have not had good luck with them being saved. As far as if you had to remove one after any amount of running. Other times you get one like this, I think it was a Murray part number, whatever. It actually has this like a peel and stick kind of backing to it. So same thing there. I'll just I won't even need to use the shellac. I'll just stick it to the housing, and then it'll bolt on. Because of the style because of the style thermostat housing this is, it takes a curved hose. So I'll actually have to trim this a little bit, but this is what they happen to have. It's a Gates number 2333. If you happen to have one like this, other ones, this one is like that because this is an aluminum housing. I don't know what I pulled it off of. I've hung onto it. It's kind of crappy, but it's a nice lightweight housing. Most of them are cast iron. So I've just been hanging onto this one for like a race application where I wanted to try to save a little bit more weight. I did sand this down to try to make the surface as good as possible. If it proves that it's leak, I'll take some of that gasket maker and smear around in the low spots next time around. Otherwise, the other factory style with the cast iron housings have a steel pipe nipple that comes out and actually faces down, and then all you need is a little short straight piece, and that's what I had running on the other end. For the bolts, I like to have something that's a flange head to spread out the load. These are just the two that were the length that I had. Just make use of them for now. I'll end up getting another one to match this later on, but like I said, I'm on a time frame to get this thing done. As far as ready for the dyno, then I got all winter before racing season. I'm just going to start by flipping this one over. Be careful not to touch the sticky side or you're going to screw up its stickiness. Especially with dirty hands like mine. I'm just going to get it lined up. Key thing here is the side to side because of the slot, but you don't want to have it shifted too far to one side and then have it interfere with getting the bolt on there. Okay. There. I have shorter versions of these, but like I said, I want enough length in there. I chose this length because it gives me at least ½ an inch of thread there, which is a big benefit for not stripping out the aluminum manifold. I wouldn't be too worried about it on this manifold because it's brand new, but I want to use a bolt that has that much thread in there because I've had problems where getting used aftermarket manifolds before where somebody tried to thread it in there where they didn't have enough thread and they've stripped out part of it, and then because it's exposed to coolant and stuff, if they're over drilled, which now that I'm saying that I should probably look and make sure because we might have to put some sealant on these. No, they're solid holes, so don't have to worry about the sealant. But you don't want to skip on the thread because it is going into an aluminum casting and you are prone to ripping the threads out. especially if you overdo it on tightening them. So what the heck, we might as well torque this one too. Because it's 5/16 threaded, it's only going to be something like 28 foot-pounds or something like that. It'd be a typical sport or typical spec. So I need to cut my hose to length. I'm just going to eyeball this. Silver Sharpie comes in handy. Now we're just going to be, if this one's pushed down on there on the way, I'm going to end up somewhere like right here, as far as all the way bottomed out. So I can just cut that hose right there. These things are made for like PVC, I think, but I find they work good for rubber. At least that's what I bought for, was for doing radiator hoses. The last notch is always a bit of a thing here. There we go. Now I can just check fit it. This hose bend isn't quite, it'll just be bent over a little bit more, but it's not enough that's going to pinch it. Obviously you couldn't make that bend with a straight piece. So. And of course about hose clamps, so I guess that's what I gotta go get. Alright, I finally got all the parts I needed torn off of the car and put on. I needed to use the distributor gear. I had to get a couple of lines switched around here after I got the headers off to check fit. I had to change the fitting on this line and reroute it a little bit, but otherwise now everything should clear. Got the drive system figured out on the front. I also did a little more research on solid roller cams, on a hydraulic roller cam. It seemed like the general consensus, rather than starting loose and tightening up with a hot lash, it would be just to set a very small amount of lash cold, and then when it warms up, just make sure that it's not enough to be making a ton of noise. This thing is now ready to get on a cart and get loaded up in the truck and ready to go to the dyno tomorrow.